హలో ఎవ్రీవన్. పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 4 మనకు క్వాడ్రాటిక్ ఈక్వేషన్స్ టాపిక్ నుంచి ఒక 2 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. ప్రీవియస్ పబ్లిక్ ఎగ్జామినేషన్స్లో వచ్చిన క్వశ్చన్స్ను డిస్కస్ చేద్దాం మనం. సీ దిస్ క్వశ్చన్. ఫైండ్ ద క్వాడ్రాటిక్ ఈక్వేషన్ హూజ్ రూట్స్ ఆర్ 7 + 2√5 అండ్ 7 - 2√5 అన్నాడు. Suppose alpha comma beta are two roots, then the equation written as x square minus sum of roots into x plus product of roots equal to 0. So here to find the equation we need sum of roots and product of roots. Yes, see the solution. Given that roots of the equation, roots of quadratic equation, they are given by 7 + 2√5 comma 7 - 2√5. I am going to write sum of roots, that is alpha plus beta written as 7 + 2√5 plus 7 - 2√5 gives the result 14. Next, I am going to write product of roots. Product of roots alpha into beta, that is 7 + 2√5 multiplied by 7 - 2√5, like a plus b into a minus b. On simplification it gives the result a square minus b square, so that 49 minus, here it is 7 square 49 minus 2√5 whole square value 4 into 5. Therefore we get 29. 7 square value 49, 2√5 whole square value 4 into 5 20, 49 minus 20 gives the value 29. Sum of roots, product of roots over. Now I am going to write required equation. Required equation, general formula x square minus sum of roots into x plus product of roots equal to 0, implies we get x square minus sum of roots here 14 into x, product of roots you have 29 equal to 0. Yes, this is required quadratic equation with root 7 + 2√5, 7 - 2√5. Let us move to the next one. Find the quadratic equation whose roots are -3 ± -5i. Same model question. Let the roots of quadratic equation are alpha equal to -3 + 5i and beta equal to -3 - 5i. Now I am going to write sum of roots and product of roots. Adding these two, plus 5i minus 5i gets cancelled and we get -6. Next, product of roots, a plus b into a minus b model, it is alpha into beta value, a square value 9, b square value 25i square. Yes, here a square is 9 minus b square value 25i square. I square value -1, so that 25 plus 9 gives the value 34. This is 2. Now required quadratic equation. X square minus sum of roots into x plus product of roots equal to 0 implies we can write x square minus sum of roots minus 6 into x plus product of roots you have 34 equal to 0 implies we get x square plus 6x plus 34 equal to 0. This is required equation. Let us move to the next one. Again, two roots are given. Then we need to find the quadratic equation. Let us suppose these two roots are alpha and beta. Let given roots of quadratic equation they are alpha, that is p minus q divided by p plus q. Next, beta is minus of p plus q whole divided by p minus q. These are given roots. Next, I am going to find sum of roots. Sum of roots and after that product of roots. Here you have p minus q divided by p plus q, first one, plus minus of p plus q whole divided by p minus q. Therefore, the value of alpha plus beta become, in the denominator part it is p plus q into p minus q. On cross multiplication what we get? P minus q whole square minus p plus q whole square. That is alpha plus beta value become, in the numerator, a minus b whole square minus a plus b whole square model it is. On simplification we get here p square q square terms gets cancelled. Minus 2pq, one more minus 2pq gives minus 4pq divided by p plus q into p minus q written as p square minus q square. This is sum of roots. Next we need to write product of roots. You have product of roots p minus q divided by p plus q into minus of p plus q divided by p minus q. P minus q gets cancelled, p plus q gets cancelled, and we get product of roots minus 1. This is second result. Now required equation I can write by the formula x square minus sum of roots into x plus product of roots equal to 0. Now required quadratic equation, we can use the formula x square minus sum of roots into x plus product of roots equal to 0. X square minus, what is sum of roots? Here you have minus 4pq divided by p square minus q square of x plus product of roots value minus 1. It is equal to 0. Therefore, x square plus 4pq divided by p square minus q square minus 1 equal to 0. Also you can simplify this, p square minus q square of x square plus, here it is x, 4pq of x plus p square minus q square, it is equal to 0. That is required quadratic equation. Move to the next one. For what values of m, the equation m plus 1 of x square plus 2 times of m plus 3 of x plus m plus 8 equal to 0 has equal roots is given. By the concept of nature of roots, if the roots are equal, then the value of discriminant b square minus 4ac equal to 0. You know this. So, first to find the value of m, here you have to use the condition delta equal to 0 due to equal roots. Yes, we know that a second degree equation ax square plus bx plus c equal to 0 has equal roots. Implies equal roots if delta discriminant value b square minus 4ac equal to 0. Here it is given that m plus 1 of x square plus 2 times of m plus 3 of x plus m plus 8, it is equal to 0. Now put delta equal to 0, implies what we get? Next 24m 36, 4m square cancelled. Next minus 36m 32 equal to 0. Yes. Now 24m minus 36m, that is minus 12m. 36 minus 32, that is plus 4 equal to 0, implies 12m equal to 4 and m equal to 1 divided by 3. Yes, this is the answer. Let us see. Given equation m plus 1 of x square plus 2 times of m plus 3 of x plus m plus 8 equal to 0 is given. B square means you have to write 2 square m plus 3 whole square here. So that we get 4 times of m plus 3 whole square value. Next minus 4 times of product of these two. 4m square gets cancelled. Simplify remaining terms, we get m value 1 by 3. So for m equal to 1 by 3, it has equal roots. Final conclusion I am writing. For m equal to 1 by 3, given equation has equal roots. That's all. Move to the next one. For what values of x, the expression x square minus 5x minus 14 is positive? That is the question. Given that x square minus 5x minus 14, this is the given expression, and I can factorize this x square minus 7x plus 2x minus 14. If you take x common, x minus 7, 2 common, x minus 7, and hence we get x minus 7 into x plus 2. Yes, the given expression. Now product of two different linear factors, x minus 7 into x plus 2 written, and given that it is positive, then find the value of x. Yes, since x square minus x minus 14 more than 0 implies, here I can write x minus 7 into x plus 2 more than 0. Here the roots are minus 2 comma 7, and the expression indicates a parabola whose roots minus 2 and 7. Yes, the expression indicates a parabola and roots are minus 2 comma 7. The expression is positive given. Yes, the expression positive means positive graph. In for what values of x? The graph is positive, parabola positive. The meaning here, that implies I can write x belongs to, here it is minus infinity, it is plus infinity. So that minus infinite to minus 2, union 7 to infinite. Or I can write x value less than minus 2 or x value more than 7. This is your answer. Let us move to the next one. Alpha, beta are roots of ax square plus bx plus c equal to 0. Then find 1 by alpha plus 1 by beta. First question. 1 by alpha square plus 1 by beta square. Second question. Yes. Whenever alpha, beta are the roots of general equation ax square plus bx plus c equal to 0, implies sum of roots written as minus b by a and product of roots that can be written as c by a not equal to 0. Yes, you know this. Question number 1. The value of 1 by alpha plus 1 by beta, that is alpha into beta in the denominator part. On cross multiplication we get alpha plus beta in the numerator part. So this is equal to alpha plus beta value minus b by a, alpha into beta value c divided by a gets cancelled and we get minus b by c. This is first one. Let us move to the second one. 1 by alpha square plus 1 by beta square is there. It can be written as, in the denominator part you have to write alpha square into beta square. Next numerator become beta square plus alpha square. A square plus b square written as a plus b whole square minus 2ab. So that here it is, in the numerator I can write alpha plus beta whole square minus 2 alpha beta whole divided by alpha beta whole square. Alpha plus beta minus b by a. Next, alpha into beta, that is c divided by a. Next, alpha into beta value c by a whole square. On simplification it is minus b square by a square minus 2c divided by a whole divided by c square by a square. Here you have denominator part a square, here also a square, but here you have only a. Multiply and divide with a here. Now neglect a square in denominator part. In each term, what we get? Minus b square minus 2ac whole divided by c square. So this is 1 by alpha square plus 1 by beta square value. Move to the next one. Find the maximum and minimum values, maximum or minimum values of the expression 2x minus 5, 2x minus 7 minus 5x square. Here we know that if a more than 0, then we get minimum value of the expression ax square plus bx plus c is equal to 4ac minus b square divided by 4a. Also, suppose if the value of a less than 0, then we get maximum value for this expression ax square plus bx plus c, and the value also equal to 4ac minus b square divided by 4a. Yes. Why? Because If A is more than 0, we get U-shaped diagram in this way. If A is less than 0, we get reverse U-shape. It has minimum value, but in this case it has maximum value, and the value 4ac minus b square by 4a is the formula. Here, since the expression 2x minus 7 minus 5x square written as in order minus 5x square plus 2x minus 7, so that here coefficient of x square, that is negative quantity. When coefficient of x square is negative quantity, then maximum value exists. Therefore, I can write maximum value of this expression. Formula 4ac minus b square by 4a, 4ac minus b square whole divided by 4 times of a. This is equal to minus into minus plus sign, 20 into 7, 140 minus 4 divided by minus 20, so that we get 136 divided by minus 20. Also you can simplify this. So the solution, you got minus 34 divided by 5. Let us move to the next question. There are two equations, they have a common root, then find the value of a. That is the question. Given that first one, x square minus 6x plus 5 equal to 0, and another equation x square minus 3ax plus 35 equal to 0. They have a root in common. They have a common root, right? Yes. This is given data. We need to find the value of a. Since x square minus 6x plus 5 written as x minus 1 into x minus 5 equal to 0 implies x equal to 1 comma 5 are roots of x square minus 6x plus 5 equal to 0. So that to the first one, 1 comma 5 are the roots. In case if 1 is root of the second one, then we get one value of a, and if x equal, in the second case, if x equal to 5, then you will get another value of a. Yes, I am going to write case 1. If suppose x equal to 1 is common root, implies x square minus 3ax plus 35 at x equal to 1 also 0. Therefore, 1 minus 3a plus 35 equal to 0. Next, 3a written as 36 implies the value of a equal to 12. Next, second case. In the second case, if the value of x equal to 5, then x square minus 3ax plus 35 at x equal to 5 equal to 0. Why? Because second equation also satisfies the root of first one, implies here we can write 5 square minus 15a plus 35 equal to 0. 25, 35, 70 minus 15a equal to 0. Yes, 15a is 70. I think it is 25, 35, 60 here. Yes, implies the value of a become 4. So either a 12 or 4. Let us move to the next one. X square plus bx plus c equals 0. X square plus cx plus b equals 0. Have a common root, then show that b plus c plus 1 equal to 0. That is the question. Let us suppose alpha is a common root of both. Alpha is a common root of both x square plus bx plus c equal to 0, comma x square plus cx plus b equal to 0. When alpha is common root of these two, then I can write alpha satisfies first equation and alpha satisfies the second equation also. This is some result 1. Now I can equate these two. Implies alpha square plus b alpha plus c equal to alpha square plus c alpha plus b. Neglecting alpha square on both the sides, b alpha plus c minus c alpha minus b is 0. If you take alpha common, b minus c. Next, minus of b minus c equal to 0. Implies alpha of b minus c equal to b minus c, and the value of alpha become 1. Alpha equal to 1 if you write in this. Now from result 1, since alpha value equal to 1 implies, here from 1 I can write alpha square plus b into alpha plus c is 0. Implies 1 plus b plus c equal to 0, or you can write b plus c plus 1 equal to 0. Yes, this is the solution. Let us move to the next one. For what values of x the expression is negative given? Yes, given that 15 plus 4x minus 3x square, it can be written as minus 3x square plus 4x plus 15. Next, I am going to factorize this. Minus 3x square plus 9x minus 5x plus 15 it is. If you take minus 3x common, here we get 3 and minus 3. Minus 5 common, x minus 3. X minus 3 in one bracket, in the other bracket minus 3x minus 5. Given that this expression is negative, write less than 0, implies it is less than 0, implies less than 0, implies less than 0, implies less than 0. Let us see. Previously you have one question. For what values of x the expression is positive is there, but now the question is for what values of x it is negative. Let us the difference between these two. In this case, coefficient of x square positive, so that U-shaped diagram is selected, but here coefficient of x square is negative, so that it indicates parabola in reverse shape. Okay. Next, one solution is 3 and the other solution here minus 5 by 3. Yes. For what values of x the expression negative is given. Here for all more than 3 it is negative, and left side of minus 5 by 3 also negative. Implies I can write x less than minus 5 by 3 or x more than 3. This is the solution for given question. Since x square coefficient negative, it is written as the graph is drawn in the reverse sense. Next, state the sign of the expression x square minus 5x plus 6. Here, both the questions, for what values of x the function is positive and for what values of x the function is negative, both given. Why? Because state the sign of the expression is given. Maybe the sign of the expression positive or negative. So that two cases arises. Case 1. Let us suppose x square minus 5x plus 6 positive. And second case, x square minus 5x plus 6 less than 0. Yes. Suppose that positive case first and then go for negative case. I can factorize this x minus 2 into x minus 3 more than 0. After factorization, this is the result. And here x minus 2 into x minus 3 less than 0. You know that this expression indicates parabolic shape graph and whose roots are 2, 3. And the expression is given as positive. For what values of x it is positive? For all x belongs to minus infinite to 2 union 3 to infinite, the expression is clearly positive. Next, less than 0 you have 2, 3 are the roots, less than 0 negative portion. For all x belongs to 2 to 3, the expression is negative. That's all. In this way, you have to explain the sign of the expression. First, write given expression. That is x square minus 5x plus 6. And after that, write the sign of the given expression. About the sign, maybe positive, maybe negative. If positive, then what happens? The value of x in between minus infinite to 2, 3 to infinity. But in the interval 2 to 3, it is clearly negative. Yes. Let us see the next question. Prove that the roots of x minus a into x minus b equal to h square are always real. What is the condition for real roots of the equation? You know that is delta b square minus 4ac either greater than 0 or equal to 0. That is delta, if suppose delta greater than or equal to 0, it has real roots. Let us cross check. Given that x minus a into x minus b equal to h square, it can be written as x square minus sum of roots into x plus product of roots in the left side minus h square equal to 0. Therefore, you can write x square minus a plus b of x plus ab minus h square equal to 0. This is given equation. Let us find discriminant value b square minus 4ac. If you find discriminant, b square is minus of a plus b whole square minus 4 times of a value 1 and c value ab minus h square. Now delta equal to, here minus of a plus b whole square value a square plus b square plus 2 times of ab minus 4ab plus 4h square it is. Therefore the value of delta become a square plus b square minus 2ab plus 4h square. Therefore delta written as a minus b whole square plus 4h square. Now square quantity always non-negative, that is greater than or equal to 0. Therefore delta greater than or equal to 0 implies, we can say that, therefore since delta greater than or equal to 0, I can say that the roots are clearly real. That's all. So most of the questions based on roots of quadratic equation, that is nature of roots of quadratic equation, and some of the questions based on common root condition and sign of the expression also. These type of questions previously asked in the examinations, so you can easily get 2 marks from this. Thank you.